In order to find the magnitude and coordinate direction angles of the resultant force acting on the bracket of the two forces in 3D space, we can utilize the Cartesian vector method. So to start, we first need to convert each one of the force into its Cartesian form. So our force F1 of 450 Newton that is in 3D space needs to be converted into its x, y and z component. To start, we have this force making an angle of 45 degrees to an axis on plane xy. So taking a cos function of 45 will project this force along our xy plane, whereas taking the sine function of 45 degree will project this force along the vertical z axis. Now, once we have the projection along the xy plane, it needs to be further projected along its y component and x component. Since the component of the force 450 cos 45 is making an angle of 30 degrees from the y-axis, taking the cos function of 30 degree will project this force along the y-axis, whereas multiplying the force component of 450 cos 45 with sine of 30 will project that force along the negative x direction. Now, once we have all the projections along x, y and z, let's write it down. So here F1 will be equals to 450 cos 45 sine 30 times negative I. Here the negative is indicating it is acting along the negative x direction, where I is known as the unit vector of x-axis. Next we have 450 cos 45 cos 30 positive j, and finally I have 450 sine 45 positive k. Now simplifying give us these values as negative 159.1 I plus 275.5 j and plus 318.2 k. Next, we have a force of F2 of 600 Newton. Now here the force is making a couple of angles with the x-axis and y-axis. Now since we are given directly the angle along the x-axis, I can figure out the projection of this force along x-axis by just taking the cos 45 of this force, and it will give me a component along the x-axis. Similarly, I can repeat this process for the y. However, we don't have any angle here for the z-axis. So if that is the case, we can utilize our relationship of cos square alpha, where alpha is the angle that this force makes along the x-axis, plus cos square beta, where beta is the angle this force is making with the y-axis, plus cos square gamma, where gamma is the angle that it makes with the z-axis. This is the unknown angle that we are looking for is equals to 1. Plugging in the values, we get the value of cos gamma equals to plus minus 0.5. Now taking the cos inverse, we get two values, one with the positive 0.5 and the other with the negative 0.5. That is 60 and 120 degrees respectively. Now in this case, if you look at the force is actually acting downwards, so it cannot be making an angle of 60 degrees with the z-axis. Here it will be making an angle of 120 degrees with the z-axis. Therefore, utilizing the gamma equals to 120, we can go ahead and finally write our F2 force in its Cartesian vector form. So to start, I have 600 cos 45 I, that is the component along the x-axis, plus 600 cos 60 j, that is the component along the y-axis, and finally 600 cos 120 k, that is the component this force is making along the z-axis. Simplifying give us the numbers of 424i plus 300j negative 300k. Now, once we have both the forces represented in terms of Cartesian vector, we can go ahead and add these forces together to figure out our resultant force. Now, here the addition happens in such a way that I component is added with the I component, J component is added with the J component, and K component is added with the K component. So if we do the sum, our resultant force is coming to 65.16 I plus 575.5J and a sum of 18.2 K Newton. Now, once we have this resultant force represented in terms of Cartesian vector, here we are looking for the magnitude of this force. So taking the square root and squaring all of these individual terms and adding them together will give us the magnitude. So the magnitude of the resultant force will be represented as a square root of 265 square plus 575 square plus 18.2 square, and this is coming as 634 newtons. Now, once we have the magnitude, the only thing that is left is the coordinate direction. Now, for the coordinate direction, we are basically looking for alpha, beta, and gamma, where alpha is the angle the resultant is making along the x-axis, beta is the angle it is making along the y-axis, and gamma will be the angle it is making along the z-axis. So to start, alpha will be equals to cos inverse of FRX, that is the x component of the resultant force, divided by the magnitude of the resultant force. Here it is getting the value of 65.3 degrees. Similarly, if I do the beta, that will be the cos inverse of the y component divided by the resultant magnitude. The value is coming as 24.8 degrees. And finally, our gamma of the resultant is cos inverse of 18.2 divided by 634, gives us an angle of 88.4 degrees. Now, once we have the magnitude and all the three angles, let's go ahead and plot this force. So our resultant vector will start from the origin and it will go into the 3D space with a length of 634 newtons. Now, since it is in the 3D space and we know that because it has all the three components along the x, y, and z axis, so it will make an angle alpha that is along the x-axis of 65.3. It will make an angle beta with the y-axis of 24.8, and finally an angle gamma with the z-axis of 88.4 degrees.